Good morning, everyone. Can you all hear me?
Yeah, good morning.
Yeah. Sorry for the delay. It was due to some unforeseen circumstance. But I guess we should just get started already. So in our previous class, we introduced TypeScript. Um, we tried to we tried to understand what TypeScript is, why we use TypeScript. We tried to also set up a basic TypeScript environment. After that, we introduced basic types, and we went over what type annotations are. We also briefly looked at type inference. And last but not the least, we completed union and intersection. So we went over all of this. And today, we'll be looking at type aliases. So what are type aliases? So in TypeScript, and types aliases allow you to create custom names for types. So they are defined using the type keyword and provide using the type keyword and provide a way to create reusable descriptive type definitions. So type aliases are particularly useful for complex types, union types, and making your code more readable and maintainable. Now, the key characteristics of type aliases are one, created with the type keyword. They are created with the type keyword. So these are editor, intersection. Good. So type aliases are created using the type keyword. So you can say something like type user is equal to, or you can say user is equal to, you see, name string, something like this. Or you can even say, okay, username is a string, like this. So they are created with the type keyword. As you can see, we use the type here. Username is equal to string. They can represent any type: primitive, object, union, intersection, function, etc. So the second characteristics of type aliases, they can represent any type. So functions, union, intersection, primitives, and even reference types like objects and arrays. The third X-tick here is they cannot be extended. They cannot be extended or implemented directly. The fourth here are compiled. They are compiled time constructs, so they disappear after compilation. So they are actually compiled time constructs. That what that means is they disappear after compilation, and they support generic parameters. So as I said, I gave you a basic example here. Type um, username is equal to this. We're trying to say username is a string. Then we can go ahead and even say age is a number. Now we can type is active, which is a Boolean, type of Boolean. Now, as you can see, each type here begins with a capital letter. So we're not doing something like type age equal to string. No. So types begin with capital letters so that in case you have something like, for example, you have const age, you see age equal to 23, something like this. So if you hover over this, age is a number, then if you say age 23, you will get an error. So let me just see A, because I think I'm getting, and we're getting this error. String is not assignable to, okay, let me just move this bit. String is not assignable to type number. So you cannot assign a string to a number. Now we have 23 here, and the error is gone. So basically, these are basic type aliases. String, age, or you can say is active, is either, let's say it can be a Boolean or null. So we learned about union. This is a union. It can be one of two types, either a Boolean or null. Okay, so this oh, basic type analysis. I'm moving on. We have object type analysis. So we can refer to this as primitive values, like the A here. This is a primitive value. So these are basic type aliases, essentially primitive type aliases. We can call that as well. So now let's look at a reference type alias like the object, arrays, and so on. So for objects, you can have something like, we've done this actually, but since we were just doing it to demonstrate, to show other examples, so now we get to understand what we are actually doing. So we have the object type alias. So we can see type object. So we have the type. Then we can say type user. So the user is an object. So ID is a string. And user will have a name, string, age, which will be a number, type number, email, which is optional, and we have will be of type string. And then we have a read only created at, which is of type date. So actually did not talk about the type date. So this enables basic storage and retrieval of date and times. So I don't need to explain. It's actually an interface date, enables basic storage and retrieval of date and time. So apart from string, number, Boolean, and the rest types, we also have date. And as we move on, we discover other types. So this is actually a read-only property. So what read-only here means you cannot change this one. You cannot change it once it's created. So a created ice is automatically generated. So you don't want to change this. So there's the reason why you're making it read-only. So that's basically it. So you can come over here. Let's see. Okay, const user is equal to, see, user is of so we've typed the user here. So we can say this is equal to, and now we have to provide all the properties, the ID, the name, age, because email is optional. We don't have to provide email. So we can say ID, which is 1, 2, 3, 4. Okay, so here. Okay, it's ID, not IS. ID. I love TypeScript. Now, if you change it to IS, we're getting an error. Now, if you hover over this, object literal may only specify non-properties, and ID does not exist in type user. So if you look at this, we are getting this error. Then when you look at your type, you see it's IS, not ID. Once you change this to D, the error goes away. Now if you hover over this, and now you get another error. Type ID string is missing the following properties from type user, which is name, age, created as. So it's trying to let us know that we have to provide the name, the age, and the created as property. Okay, so moving on, we have name, which is John, age 23. So we can provide the email if you wish to, or we can leave it if we don't. Now we can say created at, you will see new date like this. So now let's do something. Let's say user that created at is equal to new, nope, date. Okay, now hover over this now. Cannot assign to created at because it is a read-only property. So what this means is we cannot change this once it's created. Cannot change it. But if we do something like a user dot ID is equal to some other IDs, and now we can see there's no error. We are assigning to this ID another value, and there's no error. But once it's read only, you cannot reassign a value. So if you do something created that is equal to new date, cannot assign to created because it's a read only property. Great. So we've seen what read only means and what it can do. So for some of us, I am excited and I love TypeScript because TypeScript is it's great actually. It's great. It saves us a lot of trouble. Okay, so moving on, we've seen how the read only and the dates can work. So now if you come here, return the number of milliseconds elapsed since midnight, January 1st. Now if you hover over this, number is not assigned to type dates. Now if you want a timestamp, we just come over here and say, okay, this should be a number, and you are good to go. Now you have dates dot now, which is a timestamp. But if it's a date, you can't do something like dates now. You just have to do new dates. So if you have a timestamp in your database, let's say you have a timestamp of const date is equal to some timestamp that you've created using date.now, you just bring it here, pass in your date here like this. This might jet, no. Oh, E. Okay. Not really, not really. That's by the way. So, geez. Okay, so moving on, we have union type analysis. This one here is object type analysis. We have union type analysis. So for union type analysis, I believe some of us have seen this a couple of times. You can see type status is equal to, status can be of two types, pending, in this case, or approved. And then we can also say type ID, which can be of type string or number. So now we can use this to construct a complex union. We can use this to construct a complex union. We say, okay, so type response is equal to, then we can say success. But before we do that, we can, okay, we can say success true and data, which can be of type any. Then we can say or Success can be success, false, and error string. So this is our response type. Now if you hover over this, duplicate, okay, let's say res. Our response type. Now we create a function that handles response. So we say, okay, const handle response is equal to, you say response, which is of type res. Say if response, you say if response success. What do we want to do? So say log response data, else log response error. So if it's not success, then just know that there will be an error, because it's only when the response is successful that there will be data. So far as there's an error, as you can see, there's no data property here, response error. If you come over here and you say response dot, and you can only see data because the response is successful in this block. So you select data. So TypeScript is very, very useful, very useful. So this is basically complex union, as you can see, this or this. It can be one in two forms of this or this one here. And as we can see how we can handle that in our response. So moving on, we also have function type analysis. Under function, so we can type functions in different forms. So we can even, we have event handlers. We can type anything just the way we want it to be. Okay, so let's say, for instance, we have an event handler we want to type. So we just say type event handler, which is equal to event. So this will return nothing. That means void. So if you hover over this, it's a function parent that returns nothing. It's actually a void. Now we can type calculator here. It says this is equal to A, which is a number, B, also a number. I can say this one returns a number as well. This one returns a number. So this is a function that takes in a number and returns a number. So we can even have we can even type an async function that is generic. We can say, okay, type async fetcher. We say T, which is equal to it accepts a URL of type string and returns a promise. Like this. Okay, but for now, we've not treated generics, so this will be a kind of confusing. But then we can come over here and try to use our functions. We can say, okay, const handle click, handle click, which is our event handler function. Then we can say this is equal to event. Then we can just say log something like button hit. If you hover over this, it's an event handler because it takes an event and returns nothing. So it returns void. That means returns nothing, returns undefined actually. Now we can have our calculator function. We say const add, which is our calculator function. And we can say this is equal to A, B. Now it returns A plus B. So we already have this function in one of our files. So this is basically, and if you change this now to this one here, this is typed. So you cannot say return, you cannot say return a string. And once we do something like this, we get an error. Type string is not assignable to type number because it's already typed. This function will take in two parameters, A and B, and it will return a number. So anything you do is inside of this function, you will make sure a number is returned. And now you can do something like, you can say const, some calculation, some calc is equal to, you can even do things like 2, or you can some value is equal to 2, like this. And then you can return A plus B plus some value. Then if you hover over this, see to hover over this one, you see it's returning a number. So we already know what JavaScript will do here, right? Okay, this is what we call type coercion. But that's it for now because as you can see, we the error we're getting here is not assignable to type calculator. Type string is not assignable to type number. Okay, so let me just change this to add number so we know the kind of error we're getting. Okay, so now if you hover over this, type a parameter of number, B number is no, it cannot return a string. So what we have to do here is either we say, okay, pass int this number here, and then the error will go away. Or if you don't want to do that, what we do is just change this to number, and it will convert this value to a number. So this is how functions are typed. Okay, so this is basically for type analysis. We've learned about basic types, object types, function types, and complex types for type analysis. So moving on, next on our list are interfaces. So under interfaces, we have basic interface, optional and read-only properties, interface methods, interface extension, and interface versus type alias. Okay, so essentially, what are interfaces? So interfaces in TypeScript define the structure of objects, classes, and functions. So they serve as contracts that describe the shape of data and can be implemented by classes or used to type objects. So interfaces are they're just one of TypeScript core features for enforcing consistent object structures. So they also have some characteristics that we can look at. So they are defined using the interface keyword. They can be extended and implemented. So they support declaration merging. They support primarily used for object shapes. So they are primarily used for object shapes and are also compile time constructs. So once the code is compiled, they actually go away. So you can go ahead and so earlier we did something like this for the user type. So let's create another file of interface tiers. Okay, so now if it's a type, we'll do something like type, then we say person is equal to this, and then we say name string. So let's say person type. We say name string, age, number, email, which is optional and it's of type string, and we have read only. This time around, we make our ID read only. Read only ID, which is of type string as well. So now that we have our type, this is actually a type and not an interface. So how do we convert this to an interface? First of all, the structure for an interface is a bit different from type alias. So what we first of all do is remove this type, because we the first characteristics of an interface that are defined with the interface keyword. So we say interface, and instead of this, just remove this equal sign, and the error goes away. So this is a person interface. So I like doing something like iPerson because it's an interface. So since it's a person, I love doing something like this. So this is like a person interface. So I say I person, which is person interface. So now you can have a basic object, a basic person object. You can say const person. You can say, okay, so this represent the person, the I person actually that we've typed. And you can say this is equal to, you can come over and say ID 1234, name John, and age 23, like this. So say person data, do away with the error. Like, so if you hover over this, hover over I person, and by the time you comment this, you get an error saying property name is missing in type this, but required in type I person. So if you want to be able to comment this, I'll just come over to this place and make this optional. But if you don't make it optional, then it must exist in the object that you are using the I person to represent. So let's look at interfaces, like the difference between interfaces and type aliases. So I've already explained that. You can actually make this a type, copy this, bring it over here, put it here, and then change this to a type keyword. And let's say this is equal to, then change it to T person. Let's make it type person. So you can see the difference. So both can be used similarly for object types. So we can remove this, and then we can even do say this is a T person, and we don't have any issues because this is type, this is an interface. But there are places where you can't use interfaces, and there are places where you can use types. So type aliases actually. So if you come over here and change it to person interface, you're still good to go. So let's look at moving on. We look at interface extension. So this here is a remove this. Basic interface declaration. So now let's look at interface extension like this. Now, let's say we have a base interface like, for instance, an animal. Say interface animal. You see the name of the animal is a string, and Let's even give the animal an age. We see it's of type number. Now we may want to have different animals. We want to have a dog and a cat, but instead of recreating the base interface all every time, we can just come over here and say, okay, this one is an animal, but it is actually a dog. To say interface dog and say extends animal. Now we'll come over here and say, okay, breed is string and back, which is this one is a method that returns undefined, which is void. So we're getting this error because we have duplicate identifier dog union ts 15 union ts. Where's union 15? Okay, here. So we can just comment this out and we're cool. So Typescript don't want you to have naming conflict. So that's the reason why we're having those errors, because we already have dog in the same namespace here in the union TS. So Typescript doesn't want that. So this one is actually a method. So a back and make a dog back. So we have another one that we can use to extend. We have interface of cat, and this one here extends animal as well. And then we say is indoor, which is a boolean, which is of type boolean, whether the cat is indoor or not. You have mew, that is the mew here is to make the cat to make a sound. And if you hover over this, we see the file union ts 14.6, union ts line 14 column 6. So we can go ahead and comment this out. You comment this one as well, and we're good to go. So with this, we can come over here. If you want to use this, we can come over here and say, okay, const my dog is equal to, okay, first of all, the type, which is dog. I can name this iDog and iCat to avoid conflicting with what we have here. So we can essentially do this. Come back here and do iCat, iDog. You can even make this animal. And you can change everything animal to animal, and we are good. Okay, so animal like this. So my dog here is of type dog, and this is equal to an object. The name here, see, Typescript is auto-completing it for us because the base interface here, iAnimal, has a name and age properties. So the name here, let's say it is a cookie. And the age here is 3. And we can even go ahead and say, okay, the breed. Now you can see breed back and back. Okay, so we can say the breed here is okay, let's say the breed is a cookie, and then the name is Tony Max, a cookie with the sexy name of Tony Max. Okay, so now that we have this, there's something left, and we're getting this error here. This error is saying property back is missing in type this, but it's required in type iDog. This back here. Now, if you come over here and say, let this be optional. Oops, not there, not there. Okay, if you come over, okay, I guess it's yeah. If you come over here and make this optional, I say let this be optional. Then this will go away. Now our object is complete because we made this optional, and the dog doesn't have to back. But if you remove this, we get this error, and then we see back you say, okay, back some, then we get an error. So what is this error? So you just hover type string is not assignable to type. This is a method. So functions in objects are referred to as method. So this is telling you that what you declared here, what is this idog interface is actually a method. But what you are doing here is a string. So you have to do something like, since it's a method, this is how we declare methods in object. So we just say log woof. Now the dog is barking and our TypeScript is now happy. But by the time you change, okay, if you come and say mew or mew like this, now if you hover over this, TypeScript say object literal may only specify non-properties and mew does not exist in type idog. Wow. Now, by the time you come here and you say or I cat, then you add a comma. Now this becomes a union, and this object here can be of type idog or icat. So this error goes away. And if you remove the idog, now this breed here, if you comment the breed, then the back also becomes a problem because those types and properties, I mean, those method and properties does not exist in the type cat, the interface cat. So we can just undo this as well. Remove that one, remove this, and make TypeScript happy. Great. So there's also what we call multiple inheritance. So for multiple inheritance, you can do something like, okay, we can say interface I pet. You can say honor string and vaccinated, which is of type Boolean, whether the pet is vaccinated or not. Now that we have a dog and a cat as our pet, we can come over here and say, okay, interface, and then we'll say domestic, or we can make it I, domestic dog, extend, we hear it from dog and I dog and I pet. Like this, I pet. Pet. Like this. And here we will add another property, which is registered. And this will be not a string, Boolean, because registered can be true or false. Great. So now that we have this, this is basically, if you come over here and say, okay, const pet dog is equal, this is of type I domestic dog. And then you can see is equal to, and then you specify the properties owner. The owner is John. Vaccinated, which is a Boolean, it's a true. John doesn't want the dog to bite him, so he was vaccinated to keep it away from some kind of yama yama and all of those stuff. Is it registered? Yes, it is registered. Wow. Now, if you hover over this, the owner string is with the properties, breed, back, name, and age. Okay, so as you can see, we are extending from iDog and iPet. So the pet name, we also need the pet name to know which pet is vaccinated, and which pet that John is the owner. So we'll say the name here is Tony Max, and age 3, breed a cookie, and back is a method that we can just leave since it returns void. And now TypeScript is happy. But if you go ahead and comment this out, TypeScript becomes angry. Great. So this is basically interface extension. Now that we've known what interface extension is and how we can, let's say, combine multiple interfaces to come up with something more complex, let's move over to function interfaces. Now we've done this earlier, but we used type aliases instead of interfaces. So we can say interface, then we can say search function. So basically this search function takes parameters of source, which is of type string, and type string, and the second parameter substring, which is of type string as well. And what does it return? It returns a Boolean. Now we can come over here and implement our actual function. So we can say const search, we'll say search function is equal to, you can say this should be the source, this should be the substring, and we will basically return a simple search. Source includes substring, like this. So if you hover over this is the search function, this one here, it returns a Boolean. And you know how includes work. So if the substring is in the source, it will return true. If not, it will return false. But by the time you come over here and see return A, now TypeScript is not happy. And if you hover over this, it will tell you that, okay, this one here, this which returns a string is not assignable to type search function because the string is not assignable to type Boolean. So you have to change this back to what it was to make TypeScript happy and make sure your code works. So there's what we call static analysis, and we mentioned this earlier. So TypeScript helps us in that aspect. And before we even start testing anything, TypeScript is there for us. It helps us to test things and make things more efficient even before we start writing unit and integration tests. So we're confident of the code we are writing. So we're sure that nothing breaks and all of that. But with JavaScript, oh my God, I don't need to tell you what it is like. So now that we've seen basic function interfaces, we can even look at another thing. Okay, let's say this one is an interface with call signature and properties. So we can say, okay, this is an interface. Let's call this one counter interface. See, this one has a method with a parameter of start, and this start is a number, and it returns a string. also has a property of interval, which is of type number. Now this object also has a method of reset, which returns undefined, returns void. So now we can come over here and do something like this. Okay, we can say const counter, which is of type count. This counts here. And now we can say this is equal to, then we can see, okay, this one here is, this interface here has a method, start. Now, the start is a parameter we pass to this function. So we'll do something like this. Now this is, remember the structure. Look at the structure here. So we have something like start, number. And then this is a callback function actually. So we'll say return count and start. So TypeScript is not happy because the syntax is incorrect. Come over here, wrap it like this, wrap this one too, like this. Okay, TypeScript is not still happy. Then you see, if you hover over this, type is missing the properties of type counter interval. Then you see as counter. Okay, this. Okay, so now TypeScript is happy. There's what we call type assertions. We've not got into that type assertions. So we are saying, okay, counter, this is equal to start, return, count, start, blah, 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 and as counter. Okay, so now we focused on this start here because this one here, it's an interface with a core signature and properties. So if you look at this, we have the start property, which is of type number, and it returns a string. So if you come over here, this is wrapped inside of this. Now, if you see it, this inner function has a property. It has a parameter, which is this method here, the property inside of this method. So it has a parameter of start number, and it returns a string, the start here, count start. Now, we are not actually done yet. So we can say counter. Now, if you say counter dot interval, you can see because there's an interval property on this counter. Counter dot interval is equal to 1 second. There's 1000 milliseconds. Then you can say counter reset. This one is actually a method, which is a function. So this here is a, because it returns undefined, you say log counter resets. But by the time you come here and say counter dot sum is equal to sum. Now, TypeScript is throwing an error. If you hover this, sum does not exist on type counter. Now, if you look at this, we have a function in this counter with core signature and properties. We have the counter here, the function with parameter of start, and it returns a string. We have an interval, a property interval, which is of type number, and a method, reset method, which returns undefined. So we have, first of all, we have the counter. This is the function here. So we are basically assigning it to this counter here. Now, if you come over counter.interval, which is 1000, all references this. So this is basic interface with core signature and properties. So we don't you shouldn't go deeper into that because it's a kind of confusing. Wow. So um I don't want. Okay, Sakib, you want to say something? And go ahead.
Yeah, so this last one, the interface with code, signature, and properties. So it's kind of, I do not actually understand it because when we're declaring the reset method, that we added the uh, braces to signify that it's a method. But when we are doing the start uh, method, which takes a number and return a string, we did not add that braces, the brackets.
You mean this?
Yes.
Okay. So let me clarify this. Um, let me remove this and this. This is this. Can you see it now?
Yes.
Okay, so this essentially is an object. But what you are doing here, this object has two methods and one property. So the first method, methods in objects, functions in object are method, right?
Yes.
So we decided to bring this out, make this a function, and then assign it to the counter, this counter constant here. Now this is an object. Agreed?
Yes.
Okay. So now we are just evaluating this function, then assigning the result to this counter. But it's already typed. So this is an object. So now this object has properties of interval and another method of reset. So if you have in JavaScript, if you have an object of const, p is equal to, let's say it's empty, you can say p.name is equal to some name, right?
Yeah.
Because this is TypeScript, it will not allow you because property name does not exist on type empty object. So this is basically what is happening here. Okay, so in order for you to understand this, I know why you're confused. We can't really cover core signature and properties here. That is basically something from JavaScript, but you just have to look at that before you understand what's going on here.
Okay. Okay.
Yeah. Okay, so now we've seen this basic. Let's just leave it here because I know you get confused, but I suggest you should understand what core signature and properties are. Then you can come back and basically look at this. So, but it's sweet. It's sweet. Yeah. So we also have index signatures. So we can have something like we can have something like let's a typical example. Okay, let's say interface string dictionary, and then we can say okay, this one, the property. Okay, let's say the key, the property, it has a property of key. Let's say key string value number. So these are index signatures. Okay, so okay, let's say we have a const signature. or let's say dictionary is equal to dog. Let's say dog. If you hover over this is what we have. Okay, we've not, let's say string dictionary. Okay, so now we have an error. So what is the error? String is not assignable to type number. This one here is an index signature. Now, if you, okay, let's see, we have one. I'm looking for a better way to show this. Nope. Um, String is not assigned type. Okay, let's see. One is one. Okay. And we have two, which is two. We have three, three. Okay, so the key is a string. So that's the reason why we access object like this. We can do something like this to access one, because all object property keys, all object property keys are strings. So everything you've seen here is a string. So if you come over here and say something like, oh, okay, number, then you get an error. So this must be one. Do away with this. So the key must be a number. So you want TypeScript to, or you can say any. By the time you specify any, so you get an error. And in the signature parameter type must be string, number, or symbol, or a template literal type. So TypeScript is saying, no, 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 no. You cannot have the property key to be something like an object or an array. It must be string, number, or a symbol. Okay, so let's change this back to, okay, this one back to a string. Change this one to, okay, now we change this back to string and we had no errors. Now, if you hover over this one here, this thing is no longer, here it's showing number, but it's no longer number because we've changed the key to a string. By the time you try to access this, it becomes a string. Now we can extend this to add other properties like, let's say we have length, which is of type number. We have name, which is of type string. Now, if you come over here, we may have other things like this one. This, name of type string index type number. Okay, so we have our key here of type string, but the value must be a number. Now, if you hover over this, what the error is saying is property name of type string is not assigned to type string to string index type number. Now, the length number here, we do not have any errors with this because the length here, the key is a string, but the value is a number. But this one, we're trying to say, okay, the key is a string and the value should also be a string. But we've also said here that keys must be of type strings and values must be numbers. So this will not work. So we will have to eliminate this and maybe do something like any here to make TypeScript happy, but we'll get another error. So in order not to do that, we also come over here, eliminate this one, and TypeScript is now happy. And then property length is missing type, required in type style. Okay, so if you come over here and say length, say 23, because length is a required property. So any other thing you add in here is not required, but we're just trying to say any other property added is not required, but it must be the key must be a string, and the value must be a number. So you can come here and say age 28. But by the time you try to say, okay, the key is a string, and you say name, some name. Now you get an error because the value must be a number and not a string. Great. So these are index signatures. So moving on, let's look at basic class implementations. How we can use interfaces to construct classes and all of that. Okay. So let's say class implementation. Okay, so let's have a basic class of let's call this one interface drivable. We'll see the speed is of type number. Drive is a method that returns undefined. Stop is also a method that returns undefined. And now we can have another one, another basic interface, and we can call this one interface flyable with altitude of number, fly, method fly, which returns undefined, another method of land, which also returns undefined. And then we can implement, we can create a class from these interfaces. So we have, let's say we have a class of a car class that implements, we'll use the implement here, drivable. Okay, so now with this, we can go back to the characteristics of an interface, which is can be extended. They can be extended and implemented. So this simply means extended. Yeah, we extended. Okay, so we extended this property here. The iDog. This one is a multiple extension. So we extended this one here. What is it? This one, the iAnimal, and we added other properties like is indoor and meal. So they can be extended, yes. So we extended them, and they can be implemented. So we are implementing it now. Good. So that is what that means. They can be extended, and they can also be implemented. So we are implementing it now. So we say implement drivable. So the car here, missing type. Okay, so we've implemented it, but we have some required properties. So we have a required property of speed, required method of drive, and required method of stop. So we have to add all of these. So inside this, we say, okay, speed, which is a number, which is of type number, is equal to 0. If you hover over this now, it's saying, okay, it's missing properties of drive and stop because we've added the speed, but the drive and stop are still not added. Now we will say drive is a method and it returns undefined, returns void. So we say this speed is equal to 60. Then we will say log driving at this speed, driving at 60. And we still have another error. If you hover over, you say car incorrectly implements interface drivable. property stop is missing in type car but required in type drivable. Then it's showing you that interface tiers. This is our file, the interface tiers on line 99 column 2. Stop is declared here. So you should take a look at it, whether you meant to declare it or not, but you need to implement it, else make it optional. So stop is declared here. You can come over here and make stop optional and the error will go away. Now TypeScript is happy because it knows that sometimes you may need stop, sometimes you may not need to stop. But if you don't stop, oh my God, we jump somebody. So just remove this and make sure you stop. So come over here and say stop, which returns undefined. Then we'll come over here, we'll say this speed equal to 0. So we've reduced our speed to 0 and we'll say log car stopped like this. Wow. Now we've written interfaces and we've made sure that we correctly implement them so we don't have issues. And now we can even say, okay, airplane, we can declare another class and there's multiple inheritance and multiple implementation. So we have a class of car. We can say class, they will say a plane, we say implement, let's say drivable and flyable. Okay, so we can just copy all of this, bring it in here. I will say altitude equal to 0. Now, if you hover over this, now we have fly and land. So we need, let's quickly copy this because they are all void. Paste and paste. So we are getting these errors because they are duplicate methods. So we can change this one here to fly. And see, TypeScript is auto-completing it for us. And we can also change this one here to, notice when I press L, now you see A, then we'll see land. TypeScript is auto-completing it for us because, and you can see this one here, this model here saying flyable.land because it's already typed and TypeScript wants you to make your code readable, understandable, and maintainable. Great. Now, if I hit enter, the error goes away. But then this one, we change this one to a plane stopped and altitude is equal to 0. This altitude is equal to 0. Now we can come over here and say altitude is 30,000 like this. Wow. So we've seen how we can implement interfaces in classes. So we have a car class. Now, if you try to add a method that is not here, you get an error. This a breakdown. Implement drive breakdown. Okay. Okay, this is not strict. You can actually add another method. Then you can say return some breakdown. Now, if you hover over car, nope, drivable. So I want to have something that I can hover and show you the methods here. But that's by the way, this is not strict. So you can add another method and it will still work. But now this returns a string. And by the time you remove this, now if you look at this, car breakdown returns a string. That is type inference. The return type is being inferred. Now if you remove this one, if you hover over it again, it returns undefined, which is void. Great. So we also have We also have what is called declaration merging.
When we are declaring, when we are implementing more than one interfaces, so can we use union instead?
Can you use?
Union.
Oh, yeah, you can do something like that if you wish to. But in classes, unions and intersections are basically things we use in type aliases. So we hardly use them in interfaces where that is in classes, implementing interfaces in classes. But in TypeScript is a kind of a broad topic. So most times you do what you think it's good for you, what you think will enforce your rules.
But implementation is only in classes. That's where you use implementation. Or do we use it anywhere
Yeah.
else? Okay.
So we mentioned when we were talking about the characteristics, we mentioned about 5 characteristics. Interfaces are defined with the interface keyword. They can be extended and implemented. Support declaration merging. They primarily used for object shapes. Primarily used for object shapes. So classes are just blueprints for creating objects. So I guess you should get that one clear. So I believe with what we've learned so far, you should know where to use types and um, interfaces, but you shouldn't worry about that. We'll come to that too. Okay, so we've seen how we can basically implement interfaces. So we mentioned something. We mentioned declaration merging. So let's quickly look at the declaration merging. So let's say we have interface window. See, we have a interface window. And then we have a title of type string. Now let's say we have another interface. Let's actually copy this one here. Bring it here. And this one we say TS. Say type. Think this one should be capital S. Typescript API. Something like this. Okay, so this one is just TypeScript. You cannot find name TypeScript API, blah blah. Okay, this is just let's say it's a TypeScript API. Everything TypeScript has that we've been using. So let's say it's the API actually. So the window, if you say declare, if you come over here and say declare var window, and we'll say window. And now the window interface now has both title and the TypeScript properties. So we are merging this and this together. So the window, okay, so in order to do this, let's say here we have a name string. Now if you hover over this one, subsequent variable declare must have the same type. Variable window must be of type window and type of global this, but here has the type window. Okay, so global. We're not, okay, should I say this? We're not in the browser. And okay, so if you hover here, we have a window, protect window containing a DOM document and blah, blah. So what I'm trying to demonstrate here is some, and we see window. Now, if you hover over sum, has window. So this sum now has so I just want to demonstrate something. Sum that as you can see, we have sum dot name. I will have sum dot title. Window dot title. Title here is a string, and the name also is a string. But the window here, what TypeScript is trying to tell you that, okay, a window containing the DOM document, the document property points to the DOM document loaded in that window. So here I'm just trying to show you an example, declaration merging. So we've merged this with this, and this one also has the sum now has properties of title and name. But if you try to access something on the sum, and you see what is bringing here is window properties. So, but this is not what we want. TypeScript, maybe you can say something like make it like example. Turn this one to X, turn this to X. Okay, so now if you see sum, change this one to X. Now sum dot, okay, great. This is a perfect example. So this is declaration merging. So now we have we've merged these two interfaces together with two different properties. So this now has all the properties, the name and string. The name and title, which are of type string. So this is declaration merging. Great. So we've come a long way. We've seen declaration merging and all of that. Wow, this is sweet. We're progressing. This is sweet. We're moving. So actually I had this in mind to tell you earlier, but I've been forgetting. I keep on forgetting. So let me just mention it now. Coding is let me just say it's 30 or 20, let's say 20% learning and 80% doing. So there are things I will read about or I will study about, and I would think I understand them. So I start working with them, then I will discover that, oh, so I read it, I understood it, but when it's time to implement, I will not be able, because when you understand it, try to practicalize it, and if you can get it clear, that is when you know you've understood it. So I will urge you to, in any project you want to build, no matter how small the project is, build it with TypeScript, and you will be able to understand all of these things. No matter how little the project is, just build it with TypeScript. Okay, so for today, we will introduce, last but not the least, we will introduce generics. So this is a kind of an advanced topic in TypeScript, but you also have an idea about it, so you can be able to pick up from anywhere we stop. So what are generics? And why do we use generics? So generics in TypeScript allow you to create reusable components that work with multiple types with maintaining type safety. So they enable you to write flexible type safety code by introducing type parameters that can be specified when the generic is used. So basically, generics are essential for creating libraries, utility functions, and data structures that work with various types. So essentially, generics they enable you to write flexible type-safe code by introducing types parameters that can be specified when the generic is used. So generics also have characteristics that we can mention. So based on these characteristics, we can be able to identify generics and work with them. So they're defined using the angle brackets. Generics are defined using the angle brackets. So have generics TS. So generics are defined using the angle bracket. That is the first XTIC. The second XTIC is they provide type safety with flexibility. Third, they can have constraints, and they can also work with functions, classes, and interfaces. So they enable code reuse without sacrificing type information. So we can have basic, let's look at basic generic functions. All this one I'm speaking is grammar. So you won't be able to understand basic generic. No, Sekib, that is not a generic. So I understand why you're asking. This is different from this. Do you understand? This here is different from this. So when referring to unions in an array or an array type, if you don't want to do something like some array like this, or you do it array. So this is different from this. Look at this. Let's say this is an array, and this is a generic. So you can see the syntax very different. So understand that. So now that we have a basic, a generic function. So let's say we have a basic function. Let's call this function identity. Function identity. Say argument t return t to return arg. Wow. So you may be saying, what is this? I don't really, this is a kind of confusing. But before we even continue, let me show you how we can use this. Okay. Const number, okay, let's say num result is equal to identity, and we say number, and you pass in, let's say 100. If you hover over this will return number. But by the time you say, okay, you say here number and you pass in a string, TypeScript will say, whoa, yo, argument of type string is not assignable to parameter of type number. Now, if you say, okay, this is a number, or then this one is a string, TypeScript will say, yo, argument of type number is not assignable to type parameter of type string. So this requires little explanation at this level. So what TypeScript basically mean here is, okay, bro, accept argument of type this type here. So what you should return is the same type. Now, the reason why it is here is you will specify. Now, once you specify the type here, it's a type that you pass as an argument, and it's the same type that will be returned. So you can just, this is this function not generic? Okay, now you can just come over here and say, okay, string. Or let me just copy this one. paste it, and this says string response, and then change this one to string. Make this thing a string. TypeScript is happy. We can even paste this and you say Boolean response. We can remove this thing here and say true. Remove this thing. Type inference has taken place. So you can do it like this, do it like that. So, but a case where now you can see, if you hover over this, see identity, we have true, argument true, and the return type is also, the return value is also true. And by the time you come here and if you want to make it more strict, by the time you come here and say, okay, Boolean, you can no longer change this, because if you change this to a string, TypeScript say, yo, bro, argument of type string is not assignable to parameter of type Boolean. So this must be a Boolean. So this is basically the simplest form of a generic function. Okay, so let's look at generic function with multiple parameters. Okay, so let me just remove this so you get to understand that even with this basic one, without this TypeScript, we infer types. Great. So now that we've seen the basic generic function, let's implement the generic function with multiple parameters. So this we have function pair. Now in this pair we have T, we have U. And mind you, it's not necessarily T, but because it's a kind of people prefer using T for generics. So it's advisable to use T so that whenever you come across generics, you'll be able to quickly understand. So we have parameters here. We have, let's say, first T, and the second parameter, U. So what do you want to return? Return this T, U. What does this mean? Let's complete the function first. Return first, second, like this. Now let's go over here and see, okay. Const number, or let's say num string pair is equal to pair number. Nope. Yeah. Number. String. And in here you say, okay, 20, then you say 3. This is a string. And there's no error. Now if you hover over this, what's this? Let's what this is returning is an array of first, second. The first array here will be of type the first item in this array will be of type number, and the second will be of type string. So, but by the time you change this to also a number, now you get an error because this must be a number as well. TypeScript is now happy. So let's do this. We have this and that. Okay. So we can go ahead and say const Boolean number pairs is equal to pair. Then you pass in true 100. Whoa, what's this? True 100. So the types are inferred. Now, if you hover over this, we have Boolean number. Type inference has taken place. So without even specifying this, Typescript knows that, okay, you want this, and now you have this. And if you hover over this, you have Boolean number, first Boolean, second number, and it will return the first item, Boolean, the second one, a number. So gradually, and we are, wow, understanding generics. Okay, so let's look at some few examples before we can, oops. Okay, so let's look at a final example. Generic array operation. Say function get first element. So this is a generic type. And here we say array of type, generic type, array, and you say, okay, either return this type or undefined. Then we can go ahead and say, okay, return array dot length is greater than 0. If yes, return the first element of the array, else return undefined. Undefined. Like this. So now we can come over and say const nums is equal to 1, 2, 3, 4, 5. Now we can come over here and say const elf number is equal to get first element, and then we pass in numbers like this. Now, if you hover over this, you see this can be string, number, or undefined. So this one here, number blocks variable, interface TS34.5. Interface TS34. 34.5. Okay. Inference, yes, actually, inference. Where is this? 34. Make this. Okay, so the error is gone. Now, if you hover over this, you have a number or undefined. So if you do something like this, get an error. Implicitly have type any. So you can just come over here and say, this is an array of numbers. And now Typescript is happy because there's nothing it can be found that can be found in this array and to return undefined. But by the time you leave it like this, Typescript will say, yo, bro, no, you cannot, this has any type, so you cannot pass it in this because this has to be numbers and all of that. Wow. So we've seen how this works. And we've come to the end of today's class. And in our next class, we go deeper into TypeScript and look at advanced concepts and even convert some parts of our command line interface app to use TypeScript. In fact, we convert the whole application, but we won't be able to do that. We just convert some parts to completely use TypeScript so you can be able to understand how we can integrate TypeScript in our application in production. And we can also utilize bundling, compiling, and also tree shaking, minifying, and all of that. We understand what minification is, how to bundle for different environments, and all of that. So we come to the end of today's class. If you have any questions, you can go ahead and ask.